Thanks you for joining this presentation about maintaining Kubernetes Marketplace. This is part of an experimentation I've been doing with the Civo Marketplace a few months ago. So my name is Olivier. I'm working for SUSE on the Rancher side of the house. So my team is mainly working on Fleet, which is a GitHub solution you have with Rancher, Epinio, which I'll briefly talk about. So it's a platform as a service tool, one of the components of your IDP if you want to build one. And finally, Kubewarden, which is a security policy engine for Kubernetes. So you can just use whatever language as long as you can generate a WebAssembly binary. So it's a quite powerful project. I'm not a Civo employee here. I was just, based off my work on Epinio, I started using a side project named updateCLI to automate the Civo Marketplace. That was a fun experiment that we did several months ago. Otherwise, I'm also involved on the Jenkins project from time to time. I mean, less nowadays, but yeah, that's it. So my presentation is divided in 3 parts. 20 months ago, while using Epinio, why we wanted to be on a cloud marketplace. 8 months ago, how we end up using Civo Marketplace for Epinio. And 6 months ago, that automation project. So by curiosity, who's familiar with Epinio? Who heard about it? I mean, who's familiar with that logo? So, okay, nobody. That happened. This presentation is not to talk about Epinio, so the idea is it's supposed to let developers to deploy application on a Kubernetes cluster without knowing anything about Kubernetes. And it's still a young project that we are actively working on, but the thing is, 20 months ago, we were really looking for feedback from our users, and it's kind of like asking someone who knows nothing about Kubernetes to install Epinio so we can install application in Kubernetes was like, didn't work well. So we said like, maybe we could just have Epinio available on the Civo on the marketplace. So at that time, we were not talking about Civo at all. We were just interested to have Epinio on the cloud marketplace so people could just install it, try it, provide feedback. So if you're interested by Epinio, or at least the IDP topic, there is a QR code that linked to a presentation that my team is doing at the end of the month. So they will go more into the detail of that project. So to come back to the marketplace, the team wanted to have Epinio available on Marketplace. So the expectation was we wanted to go quick, it should be easy, reliable, maintainable. Our goal was to work on Epinio, not to maintain a Marketplace. So we decided to go with one cloud vendor at the time. It took the team more or less 1 year to realize that that was a total failure experimentation because the time to open a PR, nobody was reviewing our PR, so we had to wait weeks, sometimes months to get a validation. Things were working on our machine, but did not work on the cloud vendor. I mean, it sounds like a familiar story. So we didn't spend a lot of time working on that thing, but we were still looking for feedback from our customers. So that experimentation didn't work very well. Then 8 months ago, more or less, someone in the team said, okay, the first attempt to deploy Epinio on the cloud marketplace failed because nobody was on the other side, on that company. I had many discussions with that company, understood what the problem was. Basically, the team working on the marketplace left and nobody else worked on that project anymore, so we just stayed in the dark. So they said, we know what, we know people from Civo, they're a cool guy, they are pretty responsive, so what if you just deploy Epinio there? And that's how everything started. So the Civo Marketplace has just a Git repository, just drop a few files, and then you have your application available on the Civo Marketplace. It went quite well. We opened a Civo account, we submitted the application, the PR was merged 5 days later, and it was working like great. It was quick, definitely, easy, reliable. But there were just a few things in terms of maintainability. The first one was a few applications were already very old. We were testing Epinio with the latest Cert Manager version, for example. Civo Marketplace had like a very old one. They were still using the old repository from Jetstack and so on. So they were outdated applications. And the other open question we had was, what about the application management lifecycle? For obvious reason. The thing is, you can install an application on the Civo Marketplace, you can uninstall an application, but they don't tell you anything about like upgrading an application. So Depending on the type of application, you may manage the lifecycle directly from the project. For example, Jenkins, you can just configure everything from the UI. But if you want to customize the kind of application you want to have, then all you have to do is just go to the marketplace, reuse the installation instruction, for example, and then you can convert that to the tool you want to use. I'm using Helmfile or Fleet, depending on the situation, but there are many projects out there. I mean, those are just tools to deploy application. But the good thing is, if you're not familiar with the project, we could just go install Epinio, and then if you're happy with Epinio, we can just convert those installation instructions to something a bit different. And once again, our goal was to have feedback from the project. So our expectation, if people who are interested by a tool like Epinio, we want to know them and we want to work with them so we can really build the best IDP for them. And so lifecycle was not like the main priority. Regarding the outdated application, this was a really interesting problem because I saw the Civo Marketplace like many open issues where applications are just very old, nobody's maintaining them. And when you're new to a project like this one, you just expect the project to update their application. You don't necessarily know if there is a reason to use a 2-year-old application. That was for the other application. For Epinio, that was just part of the process to just look from time to time on Civo Marketplace, submit a new version, they would merge the version, so that was fine for the Epinio, because for us what was important is when someone wants to try Epinio and go to the marketplace, they just get the latest version and not the broken one which we built 2 years ago. And so that's what happened 6 months ago. We were using the Civo Marketplace for a few months now. That was working quite well. We could easily install Epinio Marketplace, which was nice. The only thing for us was the release process of the Epinio team looks like a bit like that. So when someone in the team wants to do a release, there is one person pushing a tag, like push a tag on the Git repository like Epinio, or Epinio UI backend. Strangely enough, UI backend is the front-end application, but yeah, naming sometime. And so once the application is built, when Epinio has a new version available on the GitHub release, they send release events using GitHub action. They send release event to a few other Git repositories. And on those Git repositories, that release event will trigger a tool named updateCLI. I'm coming back to this one. And that one will fetch the latest version and then update all the files on the Git repositories, open a PR if it's needed, which is obviously needed since we just released a new Epinio version. But we were missing one location, which is the Civo Kubernetes Marketplace. So that was still part of the procedure where we had to validate and merge PRs on multiple repositories. But on the Civo Marketplace, someone had to open the PR, which is like a waste of time, especially if that can be easily automated. And so someone in the team said, like, what if we could just run updateCLI in the Civo Marketplace? So I reached out to Sayam. I said, like, I noticed you have a few outdated applications. And so here is a project, updateCLI. So it's a declarative dependency manager. So that's a project that I started back then when I worked on the Jenkins project, where I was paid to break the Jenkins project. And that was a common issue, like you have a lot of Git repositories, you don't have a lot of people, it's really challenging to keep up all those Git repositories, you have a lot of files where you cannot necessarily know in advance what are the things you want to update, so the challenge was exactly the same one, so I said, oh, no, that's not what I want. So I just said, reach out to Sayam. We could just run. It's a command line tool. Assuming you have branch protection in place, there is like zero risk. You can still disable the project later if you want. So all you get is just PR open. Briefly, there are just a few wording that I want to clarify. When it comes to, for example, update automation, we have this idea of a source. So the source is where the information is coming from. And usually it's like the latest version from the vendor, from the team, whatever, whether it's internally in your organization or if it's like outside the project. In the case of the Civo Marketplace, most of the applications are just outside Civo. And when we try to fetch the latest version, that latest version can mean a lot of different things. Because for people who are familiar with the container ecosystem, latest for a tag can change over days. The same wording can have different meaning, whether you want to use semantic versioning or calendar versioning or just using hash or whatever. Sometimes people don't necessarily expect the same version, like if you have a dev team, QA team, staging, production environment, or a marketplace. And so usually this idea of using the latest information is always kind of confusing. And on the other side, you could just like use specific version. The main advantage of using specific version is you know very quickly that you have like a lot of outdated application on the marketplace, but you need to bump them. So in the case of this marketplace, the thing that we needed to update was many containers, a lot of containers, otherwise Helm charts, so that's what I found. And the other key element that I want to clarify in this case is about the target. So the target is what we want to update. So a typical scenario for a project is someone work on this, deploy an application, fetch the latest version, and then at the end of the process, just move to a different project and then come back 6 months later to realize that the project is just totally outdated, does not work anymore, whatever. And so the purpose is to go from a very like a situation that got out of control to something that is now newer that you can use again. In this case of the Civo Marketplace, I found like those three type of files. So we have the manifest.yaml, which is the file used to provide metadata to the marketplace, like the name, the version of the application, the description. And then you have either an app.yaml, which contains a list of Kubernetes resources, or the install.sh. What is annoying with the two approach for the app.yaml and the install.sh is because you don't have any structure in that file, the only way to update is by using regular expression because you don't know in advance what you want to update there. For the manifest, that's a YAML file. You have a structure, you have a convention, so you could automatically detect, okay, what you want to update. So to come back to the Siam discussion, he said, okay, we understand that you want to automate the Epinio version, but what if you just pick 5 applications and we see how it works over time? Because, putting in place updateCLI is easy. Defining what are the sources is one thing, but now to validate the PR and to merge those PR, that can be also kind of challenging. So we started with 5 applications back then, and what we quickly realized is all those applications have a different update policy. They need a different update policy because there are different applications maintained by different teams from the different side of the world with different practices. So for example, for Rancher, that's one of the projects that I'm working on, I noticed that they were using the version 2.6.0, which was from August 2021, which is bad because if we have potential users who try Rancher on the Civo Marketplace before March 2023, they just had a very bad experience because that was just a very old version. And so I had a look to those manifest.yaml and install.sh. I noticed that both files contain an Helm version from an Helm repository. So in this case, the source is a Helm repository. We fetch the version from the Helm repository. We inject that version in the manifest.yaml and into the install.sh. And if something needs to be changed, then we automatically create a temporary branch, publish that branch, open a PR, and then we ask Siam or someone else on the Civo side to just come validate the PR and merge the PR, and that's what we did. Since then, we've just been releasing multiple applications. So each time there is a new Rancher version, within the hour, there is a PR open. One of the reasons why I like this idea of using a CLI is you can just leverage CI environment. So you have like many different type of events, like on a branch change, you can trigger if you have like webhook. In this case, it's just a cron job. We run it once every hour. Otherwise, you can just run the same command from the machine, from your laptop, and then you have the same results as long as you have the same credentials. In this case, there are just one trap. The trap is, it looks like semantic versioning, it smells like semantic versioning, but Rancher is not using semantic versioning. So each time we have a patch version update, we have to carefully review the changelog because you never know what happened in those environments. And it's a pretty critical piece of information, of software. So that's one of the first traps is when you open a PR with a project, it's always to know what's the meaning of the version that the project used, because sometimes you want to pay more attention to the testing. The second thing that was interesting is the manifest.yaml is supposed to contain the version of the application, while the installation instruction usually mention the Helm chart. In this case, Helm repository just use, the both use exactly the same version, so Rancher has the same versioning. The second one was Cert Manager. It's a very popular project. The first thing that I noticed, as I said, it was like 1.5 version, really old. They were still using the old Git repository on the old organization, so I just had to update a few things. And then this time, I look at the installation instruction, and they were not using the Helm package. They were using just the kubectl command, so kubectl apply with a link to the URL located on that Git repository. So I could not just reuse the same update policy. So I had to write a second one with 3 main components, the source to target, the Git repository configuration. What was interesting in this one is I just mentioned that I want the latest cert manager version. And as you can see in the version, so we go from 1.5 to 1.12, 11, 12, then 11 again. And the reason why is because I just said that I want the latest version. And at some point, the 1.11 was the latest version. Because some teams, when projects have multiple release lines, you want to go one step further to say, okay, that's semantic versioning, then I'm looking the latest version, assuming semantic versioning, because otherwise, you just have like upgrade, downgrade, and you have to pay attention to those kind of situations. The third application we took was, okay, this time we need to monitor 2 different types of artifacts. The version want to fetch the latest version from the KDA project, while the installation instruction rely on the Helm repository. So this time we had to monitor 2 different sources, and there is one mistake in this one. I'm just curious if people can see what would happen in this case. No. So basically, the thing is nothing guarantees that the latest KDA version is the one used in the Helm repository, because it's at some point you have a pipeline issue in your release process. You just end up having like different kind of information. So the thing is, in this case, it's not that big issue because Civo Marketplace do not provide an upgrade path, so it's not that important, but sometimes we want to have like a more robust update pipeline, which bring me to the next project. So I was looking, this is the 4th application that I look at, and those are just like 4 different update policies. I could not just reuse exactly the same, which was a bit annoying. But in this case, I changed the approach. I just said, I would like to monitor the Argo CD project. So I'm just monitoring chart.yaml. I have the 2 information that I'm looking there, the app version and the chart version. So this time I said, I want those information. I run a condition, which is, do we have that Helm repository on the Helm registry? Or do we have that Helm package on the Helm registry? And if it's the case, then we open a PR. That's the only way to be sure that you have like reliable information. What was annoying, and that's a feedback that I got from Siam as well, is Argo CD does release a lot of version all the time, which means that that's a new version, that's a new PR, that's a new noise that you get, and I mean, it does not spend all this time maintaining that project. And that's one of the challenges when you want to automate updates is some projects need to move quickly, others you can just bump the version once a week or something like that. And there is no way to know this is a stable version and this is the latest development application. Each project has its own approach with this kind of policies. So I usually, for stable environment, I like to have like a stable project that I can just monitor. And then for otherwise, it's really nice because having like a lot of small releases means that you can test them all the time. So that's really great. But as an end user, like a marketplace, I would like just to have like the stable version. And I'm just bumping the version once in a while. And the Epinio is, yeah, that one was quite easy. The only thing is, when we think about the sources, you have different ways to see that problem is either you try to be as close as possible to the developer, like monitoring the Git repository that the developer are using. The good thing is you know immediately what changed. The bad thing is you can have like a lot of noise because you have to put in place more condition. I mean, do you have the artifact available? Is it publicly available and so on? While you could sometimes just monitor a Helm repository or Docker registry, sorry. Which in that case, the risk is that the project may fail to publish the right artifacts. So there is like no good or bad approach. It really depends on the project. So I can just quickly show. So for people maintaining application on the rancher or the Civo Marketplace, there is like a directory named .github. Within that directory, we have updateCLI directory with a few installation instruction, with a few documentation. And we have a directory named updateCLI.d. That's a convention that we use in the project because because we have to write manifests, we have a custom DSL, and so we leverage JSON schema store to automatically provide validation from, for example, VS Code, and for the VS Code to know that it's a YAML, it's an updateCLI manifest. I mean, you have to provide some rules, otherwise it will just try to consider it as a GitHub action or Ansible or whatever. So I'm just gonna show 3. Ask you to hold this one for me. So, okay. Thank you. So, as I said, updateCLI is a command line tool, so you can just like apply manifest, show what would change, and so on. So in this case, what I want to show is the service manager example, which is this one. So thank you. A manifest is defined such as we define the name of the pipeline. So in updateCLI, one manifest means one update pipeline. But you may have like a lot of different operations within the file. So we define the name, the pipeline ID, which is okay, pretty safe. Okay. Then we specify the sources. So we have the updateCLI core, and then we have different kind of plugins. So in this case, the source is a plugin of type GitHub release. So we need to specify where the repository is. So we have the owner, the repository. Or can I just? And the thing that I was telling about JSON schema is that you can have like also auto-completion automatically, so you can see if you want to provide more information. And for example, in this case, I will just show what it looks like. So if I run updateCLI div -config, we set start manager. We specify a values file, which I explain in 1 minute. So if I run the command locally, it will run the source. So the source, can you see in the back? So it just ran the source. It found version 1.12.4, assuming that we are looking for the latest version. It managed to find a changelog. It looked at the targets, so they are up to date, which is nice. And so we have a small explanation of what happened here. And so if we look at here, the values file is just a good way to easily change, to target different kind of repositories. So it's just a way to templatize. So in this case, I could just target my fork instead of targeting the Civo Marketplace. In this case, we are using GitHub Action, but I mean, it's just a CLI, so you just need to install updateCLI, and then you can run the command. We need to token, the GitHub token, obviously, and the username. And then if we look at what the manifest looks like is we specify the latest service manager version, that's the source. We use that information to inject by default in targets. So our target is this guy, target of kind YAML file. We have a name. We specify the SMID, which is the same SMID means that target is modifying a Git repository. So if you just remove the SMID, we just modify the file locally. We specify the file, the key, which is the YAML path key. By default, I mean, we could specify the value here, like I'm expecting this value to be in the target, but by default, it retrieves the value from the source. So each target has a default behavior. The source ID is where we fetch the default value, and then we have something similar for the installation instruction. And that's one of the really annoying thing is when you need to update files which are not structured very well like a YAML file, then you need to rely on a regular expression, which is not always super easy, but I mean, that's how updateCLI started. We needed to update Git repositories in an environment where that was not possible to detect automatically. And then we specify the Git repository where my files are located. And finally, we specify what is the action to do when a file is modified. So in this case, we have an action of type GitHub pull request. For example, if you're on GitLab, it's a GitLab merge request, for example. We can override the title of the pull request. We have like a few parameters like labels, auto merge, and so on. So those depends on the plugin. And so to come back to the story earlier here is that instead of fetching, I mean, the first thing is I'm using, I don't know if you see that here. Yeah, I'm using GitHub Copilot at the moment, and sometimes it provides me interesting suggestions, and sometimes just like not at all. So in this case, it's just plainly wrong. Kind, this one is good, same there. And instead of fetching the latest version, this one, let's say I want to fetch the version 1.10.0.x. And I specifically say, like in this case, I'm not interested by the latest version, but I want the latest 1.10. So I can just re-execute. I mean, the way the tool behaves is exactly the same on my machine or in the CI. So in this case, I found 1.10.2, which is the latest version, assuming my regular my pattern for the semantic version that I'm looking for. So this is a really simple, I would say, manifest. And so we just leave that on the Git repository, and then each time updateCLI run, it check if the thing needs to be updated. And starting from there, we can have, like, for example, more advanced, not more advanced in terms of complexity, but we can track more information. For example, this one is Kubernetes, which is one of the other projects that I'm working on. In this case, I want to monitor 4 different sources. Yes. I want to monitor the Kubernetes CRD, the Kubernetes controller, the app version, and finally the latest Kubernetes Helm chart. And then I want to update those files automatically. And so each time the project detects something, it will just open a PR. And to see what it looks like, for example, if I go to the Civo Marketplace, this is, for example, an example, bum argo cd helm to 5.45.1. The thing is, because it's you need to write a manifest, you can really customize the way you want to see the final result here. And so in this case, it detected that it found that the Helm chart is not the latest one. So at some point, someone needs to validate the PR and merge this one. While working this presentation, I realized that there were just one type of application that I did not look, which is the app.yaml. The app.yaml contains a lot of Kubernetes resources. And so I wanted to see how it works when you fetch the latest Docker image. And usually when you want to fetch the latest Docker image tag, it's always a mess because there is no rules in the the container ecosystem, so you can put whatever you want. And it's always like trying to find the right information. And the funny thing is, the behavior will not be the same depending on the registry neither. So it's always a bit of a try to see what needs to be changed. So in this case, this one, the simple keycloak, where I wanted to fetch the latest keycloak version. So it's a source of type Docker image. Voila, here is the image. I want to get the same semantic version. Okay, I still have 30 minutes left. And so I wrote multiple update policies for updating the app.yaml until I realized that they were all following the same pattern. So this time, instead of writing a YAML file, I went with a Go template because in the back, updateCLI rely on Go template. And so I just have like the default behavior, which is by updating apps file, so fetching the latest. And so these are just templated. And the value here is here. So for example, I want to fetch the latest release. Of course, you don't see that. I want to fetch the latest Redis image tag. So I need to specify a tag filter because, for example, if you want to use semantic versioning, for example, in the container ecosystem, it's quite popular to have like a tag using semantic versioning dash, for example, Alpine. And so if you want to use, for example, semantic versioning, the dash Alpine means that it's a pre-release. But in this case, in the container ecosystem, it's not a pre-release. It's like additional metadata information provided to the release. So depending on the container you want to retrieve, there's always like specific rules or different ways to handle that. And so, for example, I was just like looking at different application. And in this case, I could just show what it looks like. So in this case, instead of bumping the cert manager up, and I need to specify one additional values file. This thing is not updated, it's not published yet. The reason why is because opening PR create noise on the project, and what is important to me is that say I merge Epinio update, rancher update, cert manager update. So more PR we have there, more noise we introduce, and bigger is the chance that it will just not merge the PR anymore. So The thing is, that's one thing to open a PR when you want to submit a change. That's a different thing to validate that those changes can be merged and that you can move forward. Because, I mean, people at Civo maintaining the Kubernetes marketplace, I mean, they need to validate, they need to test it. In the end, they're the one taking the final decision whether we want to bump the version. And so here is, for example, an example. Each time I'm adding a new container to my values.yaml file, it was just detecting that we have a lot of applications that can be updated. For example, this one is Redis. We can go from the 3.2 to the 7.2. This one is RabbitMQ from 3.8 to 3.12. And so on and so on and so on. So I had a look, there are more or less 100 applications. Some applications are maintained manually by people, like for example, before FerretDB does a manual update from time to time. Some applications just rely on the latest information, whatever it means. The challenge with that is you don't really know. I mean, let's say that project has a new home and it's just moving to a different location. The thing is, you will not necessarily know that because you don't monitor the life cycle of every project upstream. And so using a version, it's usually the best way to know if that project has been updated recently, because if no commit have been done on that project for 6 months, for example, you may have an idea if the project needs to be updated or not. And the final example that I want to show you here is that we have one manifest that we want to update. We generate like an update policy where you can have like provide parameters. And the third situation is what we call the auto-discovery. So the auto-discovery is like you don't want to write a manifest in advance because you know that you're modifying files with, which follows a common pattern, for example. And so that's for people a bit familiar with depend.bot or renovate.bot. That's typically the kind of thing they do. They look at your, for example, Go mod file, they find a list of Go dependencies, and then they will submit one by one. Some are smarter than others because, for example, the challenge with depend.bot is that either it opens 100 PRs with all news updates, and you will never merge them because just way too many things to do. Or you can, for example, try to group them together. I mean, there are different approaches to handle, the noise introduced by those tools. But sometimes you just don't want to update. You don't want to have to maintain manifest. So an experimentation we've been doing in this case is another project, for example, Epinio, to come back. A typical example is a Helm chart. So a Helm chart contains two kinds of information. If either you look at the chart.yaml where you can guess a lot of information, like, for example, dependencies, so we have that information. Or we have the values file where you can put whatever you want in the values file, but we could follow some conventions, for example, the way you specify Docker image or Docker image tag. And so in this case, what I want to do is experimental. So something we've been working on is instead of having to specify the manifest, we just have like a piece of Go code that can just analyze the Git repository, and then it detects what can be updated. So in this case, it identifies for update policies, for possible update policies for Helm environments. And then it will look for it. This one, it identified Docker file, so it suggested a new version. And otherwise, for each application, it will like detect what needs to be done. And in the back, so you can see we have some updates. I mean, those are my local directory anyway, so it's not the upstream project manifest show. And what it really does in this case is updateCLI will look at the directory, detect command configuration, will generate manifest based on the context that it could find in the repository, and then it will automatically open the PR if needed. That's something that I wanted to do for the Civo Marketplace because, as you can imagine, you have 100 applications. I didn't want to write 100 update manifests, but because you have installed state, and because you have scripts there, that's a design decision that they need to do if they want to have something more maintainable on the long term. So, So to come back to my, is it this one? No. Yeah, anyway. That was a different window, but it does the work. So this was an experimentation we did. Writing the manifest was not like took me maybe an afternoon or something like this, and then we've been running those. I just added a few other manifests for other applications that I'm maintaining. I used to be a Jenkins maintainer, so I added the Jenkins manifest for it. If you are interested by providing application there and updating them automatically, feel free to reach out. We have a chat with a few people where we usually discuss about how to resolve some different projects. So before I'm finishing this talk is, the way we do is we have the updateCLI core. When we need something new, like for example, new integration, I think I'm done, thank you. When we need a new integration, we just write a piece of code that is needed for that application. So as I said, the way this project started was on the Jenkins project when I was working there. And so we use Amazon MI. So this is not a version, this is an ID, but I needed to update my Jenkins environment with those latest Amazon MI. We have like fetching Docker digest, Docker images, and so on. So when we need something new, we just add it. Last week, I got a few contributions to support Terraform, so that's something we're also working on. Usually the challenge is really about how you know the kind of information you want to monitor. So this thing is like 3 different ways to fetch an information, the same information, but those 3 different approaches have different consequences. The first one is we're using, for example, a Git tag, which means that if you want the latest Git tag, you need to clone that repository. If you have like huge Git repositories, and that's something we see from time to time on the project, you don't want to download like 3-4 gigabytes each time. So it's maybe not the best approach. On the right side, you have the GitHub release, where we are also fetching the latest tag from the same project. But the thing is, in this case, we use directly some piece of code with a GitHub API, so we have like bigger rate limit and so on. We are not affected. We can retrieve the changelog. We can find more information. And the third example is like, instead of using the GitHub release or the Git tag, we could just use a JSON plugin and query directly the API, the GitHub API. We specify a JSON path query. But the problem here is because it's not authenticated, you have like 60 queries you can do per hour, so your pipeline will be broken sooner than later. And that's something that you have is that one of the challenges when you want to fetch the latest source is what's the information you want to retrieve, what are the technical challenges, and how, for example, you sort that information. That's, for example, why we very early in the project, we introduced that idea of having like a version filter of different kind. We mainly use semantic versioning and regular expression, but we add more things as we need them. The second thing is like the conditions are ways to catch timing issues or broken pipelines. So the idea is you don't want to bump your Helm charts if you fail releasing the container image associated to your project. So that's as simple as that. Usually in this case, that was mainly using Helm and YAML file. The targets, those are the integration we have. The real challenge we have with the target is like how we handle the risk between the noise. A typical example was when we started this experimentation on the Civo Marketplace, GitHub did a pretty major update of their service, which broke updateCLI for 2 weeks. So that's where I discovered that you cannot have more than 100 empty commit on the same branch. And I had like a real lot of weird issues for 1 week. And that was nice because GitHub is not open source, so there is no way for me to know what happened there, but it was broken for 2 weeks. So it's always like, do you want to commit a lot of information? Do you want to have validation and so on? In this case, as I said, the Civo Marketplace has over 100 applications, but when you consider a project like a project with Go dependencies, Java dependencies, Docker file, and so on, you can really have like a huge amount of information you want to update. And so, yeah, it takes time to really manage the noise introducing by targets. A quick word on the action. Those are like using pull requests is super useful because it allows you to open a PR, you run the test, and if you see, for example, that's a patch update, and the test of passing, you don't necessarily have to spend more time. Just merge a PR, move to the different projects. So this is a very good way to handle the noise introduced by those updates. The auto-discovery is the thing that I was mentioning. So right now, it still is in experimental. We still really use, for example, depend.bot and renovate.bot for environment where you know what needs to be done, because that's why, this is not why we created updateCLI. We created it because we wanted to update like GitHub's repositories where we don't necessarily know in advance what's the content of the files. But at some point, we would like to be able to kind of have both, because a typical example we have on the project is like, we have some Go dependencies that have new version multiple times a day, and they just like create a lot of noise on the project. So we have like different update policies per dependency, and it really depends on the project. So, but that one is still in experimental, and we're still playing with it. Overall, there is just one thing that I wish I had, was to have first changelog for every project. You don't have to have the perfect changelog, but it's really useful when you need to update project, because there are still a lot of projects out there that just rely on the latest commit, and you're just supposed to fetch the latest commit, and you don't necessarily know why you want to bump, and looking at the Git history is not always very convenient, and just having a changelog is nice. The other thing is knowing what's the versioning of the strategy of upstream projects. Like, are they following semantic versioning? Yes, no. An example is Jenkins project has its own versioning strategy for very good reason. I'm not here, but at least there is a page that explains why they have a different versioning strategy, which means that it's easier to use. And finally, just using convention. There are many conventions out there, OCI labels, for example. Those can be really useful when you want to automate those updates, because typically the OCI labels, you can just say like, if that Docker file uses those OCI labels, you can fetch the latest repository, you can fetch then the latest version changelog, and so on. So you can build a lot of information just by following convention. Finally, I want to finish with this. Sooner than later, we pay the cost of maintenance. In the past, a typical project was someone would just work on Terraform project for 6 months, then move to something totally different, and then come back 1 year later to realize that the project is just in a broken state. The thing is, in this approach is we have updates all the time, all the weeks. We've been using that project for 3 years, I think, on the Jenkins project. And just like, it's part of the weekly duties to just look at the dependencies updates. And if we identify something that is really important, sometimes we just like open an issue, plan the work. We know that we need to test like a major Kubernetes update, and otherwise we just merge them right away. If it fails, we roll back and so on. Thank you. If you're curious by the project, it's updateCLI. If you want to know more about Epinio, which is one of the things I'm mentioning, my team is doing a public demo at the end of the month. It's an online meetup. And if you're curious about the Civo Marketplace, it's on the bottom right. Thank you. Any question?
It's all good.
Okay.
I'll speak loud. Okay. So is the automated dependency, is that only for GitHub Actions, or can I like use it in my own GitLab CI/CD if I want to update my own Helm chart repo?
The question is it only for GitHub, or does it work for other Git repositories? It does work for other Git repositories. So historically, I was using, so that's a project that I'm maintaining on the side. So usually when I work on a feature, it's because I need it for my personal usage. Sometime I add a feature because whatever reason. So we support Git, GitLab, and Stash. Stash, I was not the one being involved with that one. But the only thing is we need more, I mean, GitLab, yeah, you need to test it, and we don't have the same level of feature than we have with GitHub, because, for example, with GitHub, the 3 most interesting feature we use all the time is the auto-merge feature. So a typical example we have on many web, that's the fun part, where when you build an open source project and then you start people seeing, using it, you think about use case that you didn't think about initially. So a typical example is documentation. So when, in the case of Epinio, we fetch the latest Epinio version, and then we look for all the installation links on the Epinio website, and then we open a PR, we generate the documentation for the next version, and so on. And we don't necessarily, I mean, I don't need to review those. I can just have like auto-merge feature. If the website builds, I just continue, I don't pay attention. And from time to time, I have a PR open for some reason, because broken test or whatever. I look at it, and that's it. That's not something you have with GitLab at the moment, because it's a generic, I just like open a PR and that's it. Another feature that I like we have on GitHub is that the ability to open a PR on an upstream project. So that was something we needed initially when we wanted to work on the Civo Marketplace, because there were two solutions. Either we run updateCLI on the Civo Marketplace, and then it would just fetch the latest version, or we could just target like one of the forks we have in the team, like in mine, All Black, for example, and then automatically open a PR on the parent repository. That's also something that I saw. The funny thing was, when I reached out to Siam asking to run updateCLI, the same day someone opened a PR to allow opening PRs on the parent repository. So there were two options, and now it's possible to use both. So yeah, the thing is, we use it and we just improve it as we use it. Any other question? Thank you.